Here's how we're going to find the mean of a frequency distribution. Suppose that you're given a frequency distribution. First and foremost, we need to find the midpoints. So if you recall from earlier that the midpoint is the lower class limit plus the upper class limit, all divided by 2. Then once we have that, we take and multiply the midpoint by the frequency, which is x times f, and then we add all of those up. Now, we find the sum of the frequencies, which should be the total number of data values that you started with, n. Then to find the mean, we take the sum from part 2, divide it by n, which we found in part 3. Looking at this example here, we're already given the class midpoints and the frequency of each one of those classes. So to find x times f, you take 12.5 times 6, and that gives you 75. Then 24.5 times 10, so 245, and then we just repeat this for each row. Now that we have this, we take the sum of the frequencies, adding up this total column here, which gives us 50, and that is the number n. Then we want to do x times f, take the sum of all of those. So we're going into this column, adding them all up, and we get 2089. And so the mean of this frequency distribution, x bar, which is equal to the sum of x times f all over n, is equal to 2089 over 50, which gives us roughly 41.8. Now, if we actually had all the data values, we should be getting that the mean calculated by actually finding the mean is fairly close to this 41.8. Next, once we have our frequency distributions and we create our histograms, we can talk about the shape of the frequency distribution. There's going to be 4 main ones that we look at. A frequency distribution is called symmetric, when a vertical line can be drawn through the middle of the graph of the distribution and the resulting halves are approximately mirror images. So one example is this one on the bottom left. This is symmetric in the sense that if we put a line down here and we put a mirror on this line and looked at just this side in the mirror, we get this side right away. So it's symmetric in that sense. Another important type of distribution is called uniform, or sometimes you'll hear it called rectangular, which is when all entries or classes in the distribution have equal or approximately equal frequencies. That's this example right here. It's rectangular because it creates just a rectangle. It's uniform in the sense that the height is all the same. And now a uniform distribution is an example of a symmetric distribution, but not every symmetric distribution is uniform, something to pay attention to. Then we can start talking about frequency distributions that are kind of pushed to one side or another, and those are going to be called skewed. A little knocked off center. So we can tell if it's skewed if the graph is elongated on one side more than the other. And here are 2 examples of a skewed distribution where you see this is like a tail. Now, a distribution is called left skewed, or sometimes you'll hear it called negatively skewed if its tail extends to the left. So this is an example of a left skewed distribution. The tail is to the left. So the left is talking about the tail itself. And then there's the other, right? So there's the right skewed, which we can sometimes call it positively skewed. if its tail extends to the right. So that would be a right skewed. And notice that underneath each one of these distributions, it keeps track of the mean, median, and mode for us. So for a symmetric distribution, the mean and the median actually are either equal or really, really close to being equal. And so it's just folded right over itself. For this uniform distribution, it tells us that the mean and the median is right in the middle of this rectangle, and this has no mode because all the entries have the same exact frequency. So there's no mode for this one. For left skewed, see how the mean is less than the median. So you're going to have left skewed if the mean is less than the median. And you'll have a right skewed if the mean is larger than the median.